Yes, good evening. Good evening, Ria. Good evening. Good evening to all of you. So, everyone, please confirm, beta, am I audible? Am I visible clearly to all of you? Everyone, please confirm in the chat box, am I audible? Am I visible clearly to all of you? Audio video is clear to everyone. Please confirm in the chat box. Audio video is clear to everyone. Please confirm in the chat box. Audio video is clear to everyone. Very good. How are you all? How are you all? So, I hope you all are good and you all are preparing for the exam. And in the last class, we have covered the concept of the in the last part in the leveling. In the last class, we have done a numerical. So that numerical we have solved in the class with the help of the HI method, and there is one home assignment for you all of you, that you need to solve that same question with the help of the rise and fall method. And I hope after this class you will solve that question, you will complete that home assignment, and you can check your calculation at your own, because for the rise and fall method we are having the arithmetical check, and that arithmetical check was algebraic summation of all the four side back side minus algebraic summation of all the four sides should be equal to the algebraic summation of rise minus algebraic summation of fall, and it should be equal to last RL minus first RL. It should equal to last RL minus first RL. So that you will do. And then we have started our discussion for the geodetic leveling. So in the case of geodetic leveling, first we have covered some important terminology. We have discussed the concept of the level line, we have discussed the concept of the horizontal line, and then we have seen the concept of the effect of the curvature. So due to the curvature, what will be the error in the staff reading and what is the correction required? So error and correction, for both we have discussed how we can find out the magnitude and the nature. Similarly, we have also discussed the concept of the refraction, and due to the refraction what will be the error in the measurement and how we can apply the suitable correction. That point we have covered, and then we have discussed the combined effect of the curvature and refraction. So finally the combined correction that we have got, that was CC is equal to minus 0.0673 d square. So when I am talking about the combined correction, in the measurement we have considered the effect of the curvature as well as the effect of the refraction both. Due to the curvature there was a positive error, so that we have applied the negative correction, and due to the refraction there will be the negative error, so that we will apply the positive correction. Ultimately the overall correction will be negative. So I hope that point is clear to everyone. So we are extending our discussion. Now we will see the application, how this concept, how the expression that we have derived in the last class related to the combined correction is practically going to be useful for all of us. So let's start the discussion. Should we start our discussion now? I hope the discussion till the last class is clear to everyone. So if anyone having any doubt at any point till the last class, you can ask your doubt, you can ask your query, no problem with that. If there is any doubt at any point till the last class, all the points are clear to everyone. Very good. Very good. So now let's see the discussion. So now we are going to inverted staff topic we have already covered. Inverted staff topic we have already covered. So in this lecture we will talk about the very important concept, and that is the reciprocal leveling. So that we will discuss in the today's class. But before that we will see one more topic. So today's topic will be reciprocal leveling and sensitivity of the bubble tube. These two topics we will discuss. But before that, let's have the discussion for the next important topic, that is the distance of the visible horizon. distance of the visible horizon. So first try to understand the concept. For example, this is our earth. For example, this is our earth. In actual, we are talking about the geodetic leveling. We are talking about the geodetic leveling, yes or no? So we will consider the effect of the curvature of earth in our measurement. We are considering the effect of the curvature of earth in our measurement. So for example, this is the point A. This is the point A, and let's say I am seeing the from point A. We can see corresponding to the horizontal line that we know. We can see corresponding to the horizontal line, or you can say from point B. From point B, if I am at the height of h1, let's say I am having the height h1. So how much horizontal distance? How much horizontal distance we can see from a particular height, that I want to know. So if you want to increase the visibility of this horizontal distance, what you should do? If you want to increase this limit, you want to increase the visibility of this horizontal distance, in that case you need to increase your height, yes or no? So for example, if you are in the first floor, you will able to see a certain horizontal distance, yes or no? And let's say if you are increasing your height above the earth surface, now you are in 10th floor. So obviously from the first floor, whatever distance you will able to see in the horizontal plane, you will able to see more horizontal distance from the 10th floor, yes or no? So if we want to increase the visibility in this horizontal plane, in that case we should increase this height. So our objective is to find out, just to find out what will be the horizontal distance if our observer is having at certain height, let's say h1, h2, or any height. So from any particular height, what will be the distance of the visible horizon that we want to calculate? And if you remember the latest discussion that we have completed about the combined correction, discussed about the combined correction, so that was nothing but 0.0673 d square, yes or no? So let's say I am assuming the horizontal visible distance is going to be d kilometer between the point A and B. Between the point A and B, I am defining the horizontal distance, that is d kilometer. So don't you think that this h1 will be nothing but this should be equal to the combined correction? And this nature we can ignore, yes or no? If we talk about the magnitude of the combined correction, so that magnitude was 0.0673 d square, and this h1 or h is going to be, let's say I am considering this value as h only. Why we are considering h1? So let's say this h will be equal to, can I say this will nothing but it should be equal to the combined correction, yes or no? Can I say like this? Can I say like this? Because in this we are not considering the effect of the curvature of earth, in this we are considering the effect of the curvature of earth. So there will be while taking this measurement, there will be the combined effect of the curvature. There will be combined effect of the curvature and refraction both, yes or no? That's why we are considering the combined correction. That's why we are considering the combined correction. So we know the magnitude of the combined correction. So h will be equal to 0.0673 d square. And here if we know the height of the observer, now we want to find out what will be this horizontal distance. So from this expression, can I find out the value of d? So d, when you will get 3.855 under root h. Can I use this expression to get the value of the distance of visible horizon? Yes or no? Can I use this expression to get the distance between the visible horizon? Again, you need to remember, from this expression you will get d in kilometer and you need to put the h in meter. So we will consider the height of the observer in meter, and from this expression we can get the distance of the visible horizon. Yes or no? So this is the simple case, or we can say this is the case 1. This is the case 1 of the distance of the visible horizon when there is only one observer, and that is having the height h. That is having the height h. I hope this point is clear to everyone. I hope this point is clear to everyone. So you must have listened about the practical problem. If I talk about, that is the case 2. So for example, there is a ship. For example, there is a ship and a lighthouse. So ship are moving as per the direction provided by the lighthouse. Yes or no? So there should be a proper coordination between the ship and the lighthouse. Yes or no? If we talk about the waterways, there should be a proper connection between the ship and the lighthouse, and there should be a proper visibility so that they can communicate. Yes or no? So for example, this is your surface. This is your surface. Let's say this is the ship. Let's say this is the ship. So my drawing is very poor, so please don't mind. Let's say this is the ship. Let's say any observer is standing at the height of h1. Let's say any observer is standing at a height of h1 on the deck of the ship. So from this point, obviously if this observer is having certain height, so he or she will able to see some distance. Yes or no? So let's say from this height h1, the distance of the visible horizon is d1. And let's say on the another side, we have provided a lighthouse. We have provided a lighthouse. And let's say the height of this lighthouse is h2. So from what distance this observer will able to see this lighthouse? From what distance this observer will able to see this lighthouse? So can I say this distance should be equal to d2. So from this height h2, you will able to see the distance h1, and from this height h1, you will able to see the distance d1. So this is going to be the d1 and d2. This is going to be the d1 and d2. So this is the practical application of the geodetic leveling, as you can see. Yes. So in the question they will ask, what is the distance between the observer and the lighthouse? What will be the total distance between the observer and the lighthouse? So can I say this total distance will be equal to capital D? Yes or no? This total distance will be equal to capital D. And this capital D is nothing but this is going to be D1 plus D2. How we can find out the D1? Again, this is going to be the combined correction. So this is going to be minus 0.0673. This is going to be D1 directly we can write. This will be equal to 3.855 under root h1, and this will be equal to 3.855 under root h2 from the same concept that we have used for the case 1. So from here we can find out the total distance between the observer and the lighthouse. We can take 3.855 as common. So this will be equal to under root h1 plus under root h2. Yes or no? This will be equal to under root h1 and under root h2. Yes or no? This will be equal to under root h1 and under root h2. Yes or no? And here also you should know the units. So d we will get in from this expression the total distance of the visible horizon that we will get in kilometer if we are considering h1 and h2 in meter. if we are considering h1 and h2 in meter, so we will get the horizontal distance, or you can say the total distance of the visible horizon in kilometer, yes or no? So this is the case 2, when two observers are there having the height h1 and h2. In the previous case, only one observer was there. Only one observer was there having the height h. Having the height h. So first, everyone please confirm. The discussion till now is clear to everyone. The discussion till now is clear to everyone. Please confirm in the chat box. So this was the concept of the distance of the visible horizon. This was the concept of the distance of the visible horizon, and I hope both these cases are clear to everyone. Please confirm in the chat box if the discussion till now is clear to everyone. The concept or the discussion about the distance of the visible horizon is clear to everyone. Please explain case 2. In the case 2, there were two observers. You can consider in the case 2, there were two observers. One observer is having the height h1 and another observer is having the height h2. So what will be the total distance between the h1 and h2? This is the case 2. One observer, one observer is having the height h1, another observer, let's say, is having the height h2. So when the both observer will able to see each other, because we cannot sight in the curved surface, yes or no, we will see corresponding to the horizontal line only. Our line of sight should be all, we cannot sight in the curve, yes or no. So they will able to sight each other when this distance will be there. So when they will able to sight, what is the distance between these two observer when they are having the height h1 and h2 correspondingly? So that we have calculated. That's why we are saying this is the case 2, and here are two observers are there. So total distance total distance will be equal to d1 plus d2. Yes or no? Any other doubt to anyone? Any other doubt to anyone? So now I hope the entire discussion is now clear to everyone. So can we move further? Can we move further? Okay, so apply this concept. So this was the case 1 that we have covered. One observer. All these points we have covered. This is your case 2 when there are two observers. When there are two observers, in this case, this is going to be the total distance of the visible horizon between these two observers having the height h1 and having the height h2. So now we will solve a question based on this concept, and what will be the answer? Tell me in the chat box. So for this question, I will provide you 2-minute time and I want answer from all of you. Report your answer in the chat box and your time starts now. चौथी का आंसर आ रहा है 41.15 मीटर. बट बेटा, how you will get your answer in meter? All the options they have provided in kilometer. I have already told you multiple time, take proper care of the units. Take proper care of the units. All the options are given in the kilometer and you are reporting your answer in meter. Yes. So I hope you all have solved this question. You all can solve this question very easily. There is only one point where you can commit the silly mistake in this concept, that is the unit. That is the unit. So take proper care of the units. That's why whenever I have discussed about the curvature correction, when I discussed about the refraction correction, or when I discussed about the combined correction, or when I discussed about the distance of the visible origin. But you should not miss, dear, because in the exam, for this silly mistake, you will get negative marking. For this silly mistake, you will get the negative marking, no matter that mistake you have done intentionally or unintentionally. Yes or no? So take proper care of these things. Okay. So now let's see the discussion what they are asking in the question. Bola, an observer is standing on the deck of the ship traveling towards the port. So this is the situation. This is the ship. This is your ship. This is your ship. And an observer is standing. This is your observer is standing at the port of the ship, and it want just towards the lighthouse, towards the ports. So for example, somewhere here there is a lighthouse. Just sees a lighthouse. At the top of the lighthouse is, this top of the lighthouse is given as 52 meter. So we can consider this H2 as 52 meter, yes or no? This H2 height of the top of the lighthouse we can consider as 52 meter above the sea level, and the height of the observer eye level. This height they have provided in the question as 12 meter. So H1 is given as 12 meter, yes or no? So as per the question, from this position, the observer just sees, this is the height H1, observer just sees the light of the lighthouse. Yes. So this distance is going to be nothing but D1, and this distance is going to be D2. So they are asking about what is the distance between the observer and the lighthouse. What is the distance between the observer and the lighthouse? So that we can calculate very easily. So this total distance is going to be D1 plus D2. This will be equal to 3.855 under root H1 plus under root H2, yes or no? So D we will get in kilometer if we are taking H1 and H2 in meter. So you know the value of the H1. So H1 is your, so D is going to be 3.855. This will be equal to under root 12 plus under root 52. You can solve D, you will get in kilometer. D you will get in kilometer. So root 12 plus root 52 into 3.855. 27. 12 is given, na? Root 12 plus root 52 into 3.855. 41.15. 41.15 kilometer. 41.15 kilometer, yes or no? So let's see the option. Yes, they have provided this option. So for this question, A is going to be the correct answer. For this question, A is going to be the correct option. So I think simply very easily you can apply this concept of the distance of the visible horizon, yes or no? Any doubt to anyone at any point? Any doubt to anyone at any point? You can ask your doubt, you can ask your query. Now I think the discussion about the distance of the visible horizon is clear to everyone. And this distance we have calculated by considering the combined effect of the curvature and refraction. Again, I am repeating, in the practical situation, whenever we will take the measurement, whenever we will do the leveling work, always there will be the combined effect of the curvature, and there will be the combined effect of the curvature and refraction. Yes or no? So this was the discussion related to the geodetic leveling. Now we will see another very important topic, and from this topic you can expect a 2-mark problem in your exam, and that concept is the reciprocal leveling. That concept is the reciprocal leveling. This topic is important. So from this topic you will get 2-mark problem in your GATE exam. From this topic you will get 2-mark problem in your GATE exam. So now we will have the discussion. Now one by one we will discuss all the aspects of the geodetic leveling. So this method of the leveling, this is the method of the leveling, this is the way of the leveling. So can you please tell me what was the objective of the leveling? What was the object? I'm not talking about the plane leveling, I'm not talking about the geodetic leveling. In general, if I talk about the objective of the leveling, so what was the objective of the leveling? Measure the vertical distance, or more precisely you can say to define the reduced level of the point. Whenever I will use the term reduced level, that automatically by default it means we are measuring the vertical distance from the mean sea level. All these points now you have done. Now all these points are clear, yes? So whenever I will use the term reduced level, that means we are taking the measurement from the mean sea level, yes or no? Okay, so no problem with that. So as we know, कि whenever the distance between the instrument and the staff will be more, as the distance between the instrument and the staff will increase, the combined correction will also increase, or you can say the error due to the curvature and error due to the refraction will also increase. If the distance between the level instrument and the staff is less, there will be less error. If the distance between the staff and the level instrument is going to be more, so in that case there will be more error due to the curvature, due to the refraction. So that was already we have discussed in the case of starting, that the plane survey is suitable for the small area. So for a small linear measurement, for a small angular measurement, you can consider the earth surface as a plane surface. But if we are talking about the large area, if we are talking about the large measurements, in that case there will be more error, and that error you cannot neglect. A small error in our measurement that we can neglect. Small errors can be neglected, but the large error will not be neglected. Otherwise, what will be the benefit for collecting the data, for collecting the information, if our information is inaccurate? Yes or no? I hope this point is clear to everyone. Yes or no? So, as we know, as the distance between the level and the staff will increase, definitely there will be the large error, and for that we need to apply the curvature correction, refraction correction, or simply you can say in this situation we need to apply the combined correction. But when we are going to use this method of the leveling, that is the reciprocal leveling, so first try to understand this point. So let's say, for example, there is a hilly area. For example, there is a hilly area like this. For example, there is a hilly area like this. Or you can say there is any river. There is any river or obstruction like this. And let's say we are having 2 points. This is the point A and this is the point B. This is the point A, or this is the point B. This is the point A and this is the point B. So now, if I want to perform the leveling work in this situation, so we have discussed about the HI method, we have discussed about the rise and fall method. For that, various staff readings were required, yes or no? But in this case, when there is an obstruction like river or the ground is undulated, we cannot take the staff reading between the point A and B. We cannot take any staff reading between the point A and B, yes or no? In that case, we cannot take any staff reading between the point A and B. It is not possible to take the staff readings. So these types of the situations will there. Then we will apply the concept of the reciprocal leveling. When the 2 points A and B are far away, when the 2 points A and B are far away and intermediate stations are not available, we cannot take the staff reading between the point A and B. In that situation, we have one method for the calculation of the RL, for finding the RL, and that concept is known as the reciprocal leveling. That concept is known as the reciprocal leveling. So as of now, I have discussed when you are going to use the reciprocal leveling. So if we talk about the various methods of the leveling, like fly leveling, you are going to put the instrument at one position and you will take the staff reading on the various, like that we have done in the case of numerical. So that leveling method of leveling was the fly leveling. So sometimes you are also measuring the elevation with the help of the boiling point, yes or no? So there are various ways how with the help of those methods you can find out the RL of the points. So for example, if this is the situation, is there any obstruction are there, and if you want to do the leveling work, we want to know the RL, how we can do the leveling, that we will see with the help of the reciprocal leveling. So where we will use the reciprocal leveling, I hope this point is clear to everyone. Yes or no? And another important thing about the reciprocal leveling. So this is the advantage of the reciprocal leveling. Like if we are going for the reciprocal leveling, at the reciprocal leveling work, there will be no requirement of the curvature and refraction correction. So we will see how. But as of now, we can discuss in the case of reciprocal leveling, in the entire leveling work, you need not to apply any correction for the curvature, any correction for the refraction, no matter what will be the distance between the point A and B. We have just discussed, sir, if the 2 points are A and B. Yes, this is the geodetic leveling. Geodetic leveling means when you are considering the effect of the curvature. There will be the effect of the curvature. The error will be there due to the distance between the point A and B. That error will not depend upon the method. Error will not depend upon the method. Error will depend upon the distance between these 2 points. If the distance between these 2 points is less, there will be less error. If the distance between these 2 points are going to be more, there will be more error. So it is not dependent upon the HI method or rise and fall method, or you can say the reciprocal leveling method, yes or no? But I am talking about the advantage, and we will see how it will happen. So if we are applying the concept of the reciprocal leveling, to in the case of reciprocal leveling work, you need not to apply the curvature correction, you need not to apply for the refraction correction. Whether you are going for the geodetic leveling, no problem with that. If you are doing the geodetic leveling with the help of the reciprocal leveling, in that case also you need not to apply the curvature correction, you need not to apply the refraction correction. In other words, we can say there will be no effect of the curvature, there will be no error due to the refraction in the case of reciprocal leveling. So this is the first advantage. We will not apply any curvature correction, we will not apply any refraction correction, we will not apply any combined correction, irrespective of the distance between the point A and B. Whatever may be the distance between point A and B, if we are doing the leveling work with the help of this method, that is the reciprocal leveling, we will not apply any correction. Any correction is not required because there will be no error due to the that is the discussion, sir. How it is possible? That is the next discussion, yes or no? Sir, if the distance between the point A and B is more, then how you can say that there will be no error, there will be no correction required due to the curvature and refraction? That we will discuss when we will talk about this method. So this is the first advantage, you can say. Next advantage of this method is we can find out the collimation error. We can find out the collimation error. So sir, now this term is new to me. We can find out the collimation error. So what was the line of the collimation? How we have defined the line of the collimation? So in the case of plane leveling also, whenever we have taken the staff reading, we always tried that the line of sight should be perfectly horizontal. Yes or no? In the case of plane leveling also, whatever staff readings we have taken on the ground, all those readings we have taken corresponding to the horizontal line. Yes or no? Corresponding to the horizontal line, yes or no? So how you were ensuring that the line of sight is perfectly horizontal or not? How you were ensuring that the line of sight was perfectly horizontal or not? You have already ensured. Before taking measurement, as you know, first of all we will perform certain temporary adjustment, and we have discussed about the level of the instrument. Do you remember? In the yesterday's class we have discussed about the temporary adjustment. That was the first was the setting up, second was the leveling, and third was the focusing of the eyepiece and objective piece. So when we have leveled the instrument about both the axes, x-axis and y-axis, with the help of the leveling screw or foot screw. Do you remember this point? Yesterday we have covered this point. What are the various temporary adjustments required in the case of level that we have discussed in the last class, in the yesterday's class, and I hope you all are remembering. Yes, 3-foot screw were there. So leveling screw or foot screw were there. So with the help of the leveling screw or foot screw, we can ensure that the telescope should be perfectly horizontal. Yes or no? The telescope should be perfectly horizontal, or to just for the surety, there was a bubble. There was a bubble, yes or no? There was a bubble. So if the bubble is at the center, so we were confirmed that yes, now the instrument is perfectly leveled. And if the instrument is perfectly leveled, now we can take the staff readings. Yes or no? So for example, this was your telescope. So let's say this is your eyepiece and this is your objective piece. And if this is perfectly horizontal, so if you observe the bubble tube, so let's say this was your bubble tube. So you will see the bubble is going to be at the center. Of this tube. So we can say, yes sir, now this line of collimation is perfectly horizontal. Or now this line of sight is perfectly horizontal, yes or no? This was the way. The bubble should be at the center, yes or no? The bubble should be at the center. So this is your level tube or bubble tube. This is your bubble tube. So this is your bubble tube. So if the bubble is at center, we can consider now the instrument is perfectly horizontal. But there may be some instrumental error. And what is this instrumental error? Let's say this instrument is faulty. Let us consider this instrument is faulty. What is the fault in this instrument? When the bubble is at center, at that particular point also, let's say this is the position of the line of sight. Obviously the diagram is not in scale, so this much more angle not will be there. Just to provide you the understanding, I have considered the extended version of the diagram. What it means, कि we are saying कि sir, yes, the bubble is at center. So if the bubble is at center, what we are assuming, this line of sight is perfectly horizontal, and if this line of sight is perfectly horizontal, we are taking the reading on the staff. But in actual, what is the issue? The bubble is at center, but this is the position, this is the inclined position, this is the inclined position of the line of sight. It may be upward, it may be downward, both the cases will be there. It may be upward or it may be downward depending upon the instrument. So at that case there will be error, yes or no? At that case, when you are considering your line of sight is perfectly horizontal, but in actual the line of sight is not perfectly horizontal, it is inclined either in upward direction or in downward direction. In that situation, whatever staff readings you will take, are going to be incorrect, yes or no? In this situation, in this condition, whatever staff reading you will take are going to be incorrect, yes or no? So can I say this error? This error is introduced in our measurement due to the collimation line, due to the faulty instrument. So that's why we are defining this error as the collimation error. And with the help of the reciprocal leveling, if there is any instrument which is having the faulty level tube or the telescope, so you can find out the magnitude and the direction, or you can say as the nature of the this collimation error. So for any faulty instrument, if you want to find out the collimation error, in that case also you will go for the reciprocal leveling. So in the theoretical question they are asking frequently, कि if we are going for the reciprocal leveling, what are the various advantage of the reciprocal leveling? So now I am summarizing. In the case of reciprocal leveling, there will be no correction required due to the curvature, due to the refraction. And with the help of the reciprocal leveling, we can also find out the collimation error. Here I have discussed what was the collimation error. Now I think the discussion is clear to everyone. So now let's see this discussion. Now you can go through all the points. When it is necessary to carry the leveling across the river or any obstacle requiring a long side between the 2 points so situated that no place for the level can be found, from which the length of the foreside and the backside will be even approximately equal. That means there is no point from where we can take the staff reading between the point A and B. Due to this obstacle, then in that case we will apply this method, and that is the method of the reciprocal leveling. And when we are adopting the reciprocal leveling, when we are following the reciprocal leveling, error in the instrument adjustment, we can find out the collimation error, there will be no error. And combined effect of the earth curvature and the refraction of the atmosphere is neglected. So there will be no error. There will be no error due to the curvature. There will be no error due to the refraction if we are doing the reciprocal leveling. Now I think all the term in this slide is clear to everyone. Yes or no? The discussion till now is clear to everyone, yes or no? Please confirm in the chat box. So this was the theoretical discussion related to the reciprocal leveling. This was the theoretical discussion related to the reciprocal leveling. Till now, if anyone having any doubt at any point, whatever I have discussed till now, then you can ask your doubt, then you can ask your query. You can ask your query. Can we move further? Can we go for the further discussion? Yes or no? Can we go for the further discussion? Okay. So now let's see how we will perform the reciprocal leveling. So this is the two-step method. This is the two-step method. Listen carefully. So for example, there is a point A. For example, there is a point A, and let's say this is the point B. These are the 2 points situated apart from each other, and there is an obstacle in between the point A and B. There may be any position. It may be also possible that point A is at lower elevation or point B is at higher elevation, or this is the case. Yes or no? So in the first step, what we will do? We will place the level. We will place the level near point A. We will place our level instrument near point A and take staff reading. And take staff reading. And take staff reading at point A and B. So this is going to be the first step. This is going to be the first step. So let's see how. So let's say first we have put our instrument near to the point A, something like this. So this is your level instrument, yes or no? So this is going to be the horizontal line. This is going to be the horizontal line, yes or no? This is going to be the horizontal line. This is going to be the horizontal line, yes or no? Now what I will do, now I will take the staff reading at point A, and at point B. Now I will take the staff reading at point A and at point B. Why do we need to perform reciprocal leveling? What I was discussing from the last 20 minutes? What I was discussing about the reciprocal leveling. We can measure elevation A and B separately. How you can measure? Tell me now. So I am not saying always you are going to perform the reciprocal leveling. This is the method of the leveling. Based on the site condition, based on the suitability, you can go. So if you want to find out the RL of the any point A or B, that in that case some point should be there na, because we are talking about the relative position of the point. We are talking about the relative position of the point. So again, all the methods are not suitable for all the conditions. Yes or no? That we have already covered. So we are discussing about the various method. Which method suits you at your situation, at your site condition, you can go for that method. But we will discuss all the methods na. So for example, for the measurement of the distances, when you can measure the distance with the help of the chain, why you have discussed about the tape, and why you will discuss about some more instrument to measure the distance. We have already discussed the measurement of the horizontal angle. So why we will discuss about the theodolite? With the help of the compass, we can measure the horizontal angle, na? But again, still we are discussing some different methods, some different instruments. Yes or no? So whatever it suits you, you can go for that. Yes. So let's focus how we can perform the reciprocal leveling. So in the step 1 of the reciprocal leveling, what we will do? Listen carefully. In the step 1 of the reciprocal leveling, what we will do? We will place the instrument near A. As you can see, we have placed our level instrument near A, and now we will take these two staff reading. Let's say this staff reading is HA and this staff reading is HB. In HA and HB, which reading is going to be incorrect? Or you can say, which reading is including the error? HA or HB? We have taken two staff readings A and B. Can you please tell me Which reading will have the error and why? Which reading will have the error and why? So you can clearly say कि sir HB is must be the incorrect reading. HB must be the incorrect reading because the distance between the level and the point B is more. As you can see, this A point is very close to the instrument position. That means there will be very less error, and that error you can neglect because the distance between the staff and the level instrument is very less. So can I say, see carefully, can I say correct staff reading, correct staff reading, correct staff reading at A is going to be HA? Yes or no? Incorrect staff reading, incorrect staff reading at B is going to be the HB. This is going to be your HA and this is going to be HB. Yes or no? So can you please tell me what will be the correct staff reading? What will be the correct staff reading at B? What will be the correct staff reading at B? So sir, let's go back to the basic. So you were discussing, sir, we want to take the corresponding reading corresponding to the horizontal line, but in actual we are taking the reading corresponding to the deflected line. Corresponding to the deflected line, and this was the total correction required. This was the total correction required, and that was the combined correction. Yes or no? Tell me. Yes or no? So if we are considering the effect of the curvature and refraction, if we are considering the effect of the curvature and refraction, we should take the reading corresponding to the level line, but in actual we are considering the effect of the curvature or refraction. So we are taking the measurements corresponding to the deflected line. So in this way you can see, when we have placed the instrument near A, so staff reading at A was HA, this is correct. Staff reading at B we are getting is HB. Correct reading should be equal to HB minus C. Correct reading should be equal to HB minus C. So in this staff reading, we can apply the combined correction. C stands for the combined correction. Then we will get the correct staff reading at B, yes or no. So here we have considered the effect of the curvature. Here we have considered the effect of the curvature plus effect of the refraction. That's why we are applying the combined correction. That's why we are applying the combined correction. Yes or no? So, if I want to know what will be the elevation difference between the point A and between the point B, so let's say this elevation difference is capital H. If I want to find out the elevation difference between the point A and point B, so how can I find out? With the help of these readings. Can you tell me? If I want to find out the value of this H will be equal to, so I will say this will be HB, this reading is HB minus C. में से अगर मैं माइनस कर दूं HA, तो I can write H will be equal to HB minus C minus HA is going to be the capital HA. Do cross check. Do cross check. HB minus C minus HA will be the elevation difference between the point A and B. Make sure. Yes or no? HB minus C minus HA, it should be the elevation difference between the point A and B. Just observe the diagram carefully and then confirm in the chat box if the discussion is clear to everyone. If the discussion is clear to everyone, please confirm in the chat box how we can find out the elevation difference between these 2 points A and B with the help of the staff readings. So here we have applied the correction for the curvature and refraction. In the step 1, we have applied the correction for the curvature and refraction, yes or no? But sir, earlier you are telling that there will be no correction required for the curvature and refraction in the case of reciprocal leveling. And why here you are applying this correction? As you mentioned earlier, you mentioned in the introductory part, in the case of reciprocal leveling, there will be no correction required due to the curvature and refraction. But here you are using the combined correction. Here you are using the combined correction, yes or no? So this should be your query. This should be your query. So do you have this doubt? Do you have this query, yes or no? So as of now, the concept of the reciprocal leveling is not completed. The process of the reciprocal leveling is not completed. So let's move further. So these are not final conclusion that we are going to draw. This is the only step one you can see. This is the step one of the reciprocal leveling. अभी ये process complete नहीं हुआ. Now the entire discussion about the reciprocal leveling is not completed yet. Yes. So should we move for the next step? Should we move for the next step? So now what I will do? Now I will shift the instrument. In the step 2 what I will do? I will place the level. Near point B and take staff readings at A and B. So let's say this was the situation, same points are there. This was your point A and this is your point B. Now what I will do? I will place this instrument, level instrument, near point B. So now the instrument position will be something like this. So now let's say this is the position of the instrument. Now let's say this is going to be the position of the instrument, yes or no? This is going to be the position of the instrument. So this is going to be your horizontal line. This is going to be the horizontal line, yes or no? From the point B, if I talk, this is going to be the horizontal line. Now I will take the staff reading at A. This reading, let's say I am representing with the help of HA prime, HA dash. And I will take the staff reading at B. And this is staff reading we are representing, that is going to be HB dash. HB dash. Again, can you please tell me which reading is going to be the correct, A or B? So I can say correct staff reading at point B is going to be the HB dash, yes or no? Correct staff reading at point B is going to be HB dash. But if I talk about the incorrect staff reading at point A will be equal to, so this is going to be HA dash. Again, why this reading is incorrect? Because this reading you are taking corresponding to the deflected line. So again you need to apply this correction. Again, there will be the effect of the curvature. And the refraction for the staff reading at A. So can you please tell me what will be the correct staff reading at A? Now can you tell me what will be the correct staff reading? At point A? So this is going to be nothing but HA dash minus C. Yes or no? So this should be the correct staff reading at station A if we are applying the correction for the curvature, as well as we are applying the curvature correction for the refraction. Now again, if I want to find out the elevation difference between the point A and B, We are just shifting the instrument from point A to point B. Yes or no? Point A and point B are fixed. Yes or no? So there will be no change. So now can I find out this elevation difference between the point A and B from the step 2? From the step 2. So this is going to be nothing but HB dash minus, this is going to be HA dash minus C. Tell me. Take your time. Take your time to understand all these points. If the discussion is clear, then only confirm in the chat box. And these formulas are not required. This is the discussion that we are doing just to understand the concept of the reciprocal leveling. Just to know about the basics of the reciprocal leveling. HA is dash is RL. How you can say? What you are saying, Liz? Already I have told you HA dash is the staff reading at point A. HB dash is the staff reading at point B. So where the RL comes into the picture? These are the staff readings. Earlier these readings were HA and HB. Now when we have shifted the instrument, so I am representing these staff readings with the help of HA dash and HB dash. So how you are getting confused with RL? HA, HB, HA dash, HB dash are the staff reading. HA, HB you have taken when the instrument was placed near A. HA dash, HB dash we are getting when the instrument is placed near B. Yes or no? Yes or no? Tell me. When we are shifting the instrument from one position to another position, instrument reading, staff reading will also change, na? Staff reading will also change, na? Please confirm the point is clear. Please confirm the point is clear. What is this HA, HB? Why you are subtracting HA dash minus C from HB? HA dash minus C. Because I want to find out this elevation difference between the point A and B. I want to find out the H is the elevation difference. H is the elevation difference. H is the elevation difference between point A and B. So if we know the RL of the point A, if we know the RL of the point B, if we know the RL of the point A, if we know the RL of the point B, so from both RL we can directly get this value H. HV reading is, take your time and put your comment correctly so that I can answer. Take your time. If we know the RL of these 2 points, then for example point A is having the RL 100 meter, point B is having the RL 105 meter. What will be the elevation difference between these 2 point A and B? Tell me in the chat box. Point A is having the RL of 100 meter, point B is having the RL of 105 meter. So what will be the elevation difference between point A and B? Answer is 5. But here we don't know na RL of these 2 points. Here we don't know. If we know the RL of both the points, why we will go for the leveling work? So let's say if we know the RL of the point A, we want to calculate the RL of the point B, then we will go for the reciprocal leveling. If we know the RL of the point B, we want to know the RL of the point A. In between, we cannot take the staff reading. That's why we have selected that we will go for the reciprocal leveling. Yes or no? So, if both the RLs are known to us, why we will go for the reciprocal leveling? there must be a RL that you want to know. Yes or no? So from these two points, you will have the RL of only one point. From with respect to that point, you want to define the RL of the another point. From the known RL, you want to calculate the unknown RL. For that, we have opted this method, and that is the method of the reciprocal leveling. That is the method of the reciprocal leveling. Now I think the point is clear to everyone. Yes or no? So capital H is the elevation difference between the point A and B. And that elevation difference we can find out with the help of these staff readings. Yes or no? So I hope the discussion till now is clear to everyone. From both the step, listen carefully. From both the step, you are getting the elevation difference H. From both the step, you are getting the elevation. Let's say this is your equation number 1. Let's say this is your equation number 1. And let's say this is your equation number 2. So now can I say from equation number 1 and 2. So let's write this equation first. HA is equal to HB minus C minus HA. So H equal to HB minus C minus HA. This was the equation number 1. Equation number 2 was H is equal to HB dash minus HA dash minus C. Yes or no? HB dash minus HA dash minus C. This is your equation number 2. If I am going to add these two equations, so can I say 2H will be equal to what I can write? HB minus C minus HA plus HB dash minus HA dash plus C. Can I write like this? Tell me. If I am adding the equation 1 and 2, I will get this result, yes or no? Tell me in the chat box. If I am adding these two equations, why you are getting the different reading at B? Matlab, whenever you will place the instrument near A and when you will place the instrument near B, you will get the same reading. When you will place the instrument near A, when you will place the instrument near B, you will get the same staff reading. When you are placing the instrument near A, you are getting the reading, let's say HA and HB. When you will shift the instrument, how you will get the same reading, dear? How you will get the same staff readings? How you will get the same staff reading? What are you talking? How you will get the same staff reading? This is the geodetic leveling. Let's see. For example, this is the surface. This is the point A. This is the point B. Both the points are having the same elevation. Both the points are the same at the same plane. I have placed the instrument here. I have taken this reading. Let's say this is 1 meter. I have taken here reading. This is going to be the 1 meter. But if these points are having the different elevation, so let's say this is the point A and this is the point B. Or when you have placed the instrument here, so you will get some reading here. Let's say this reading you are getting as 1 meter. So this reading you will get, let's say 2 meter. Let's say. So this is the situation. Yes or no? And when you will shift the instrument near B, these readings will change. So how you will get the same reading? When you are shifting the instrument, because these 2 points are having the different elevation, how you will get the same reading? Now I think your doubt is clear. Now I think your doubt is clear, yes or no? Please confirm in the chat box. Is there any other doubt, any other query? Is there any other doubt, any other query? So make sure your all doubts and queries are clear, because now we are going to draw very important conclusion from the reciprocal leveling. So whatever we have discussed initially about the reciprocal leveling, I am going to prove all those points. So I hope the discussion till now is clear to everyone. Yes or no? So can I rearrange these terms? This is the plus C, this is the minus C. So can I write this will be equal to, this will be equal to, this will be equal to 2H will be equal to HB minus HA and plus HB dash minus HA dash. Can I write like this? So from here can I find out this H will be equal to HB minus HA plus HB dash minus HA dash by 2. Tell me yes or no. Now can I find out the elevation difference between these 2 points? H will be equal to, can you see in this final expression, there is no term related to the curvature correction, there is no term related to the combined correction, there is no term related to the reflection correction. These H, in the case of first case, HP was the incorrect reading. In the case of step 2, HA dash was the incorrect reading. No matter, with the help of the incorrect reading, without any applying any correction for the curvature, for the refraction, ultimately you can calculate the elevation difference between the point A and B directly with the help of these incorrect reading also. So you need not to apply the curvature and correction, curvature correction, refraction correction for the reading. Then you will calculate the elevation difference. Directly you can calculate the elevation difference between the point A and B. Here you can see from this observation. In this expression there is no term related to the, let's see. From the case 1 you can see, this HB was the incorrect reading. Yes or no? From the step 2 you can see this HA dash was the incorrect reading, but here with the help of this HA, HB and HA dash, or you can say with the help of these incorrect reading itself, we can find out the correct elevation difference between the point A and B. Yes or no? So that's why initially you have said that when we are applying the reciprocal leveling, there will be no correction required for the curvature, there will be no correction required for the refraction. I hope this point is clear to everyone. I hope this point is clear to everyone, yes or no? So why there is no requirement of the curvature correction? Why there is no requirement of the refraction correction? This point is clear to everyone, yes or no? So let's summarize. What you have to do, just first place the instrument near A, take the staff reading on both the points, and those readings are HA and HB. Then shift the instrument, place the instrument near B, again take two staff readings, HA dash and HB dash. And with the help of those readings, you can easily calculate the elevation difference between the point A and B. And now let's say if RL of point A is known, let RL of point A is known to you. Now if I am asked about what will be the RL of the point B, for this example, can you tell me if the RL of point A is known to us? If the RL of the point A is known to us, can you find out the RL of the point B? Tell me. If the let us assume The RL of the point A is known to us. Now how we can find out the RL of the point B? Now how we can find out the RL of the point B? So yes, RL of B plus H. RL of B we have to calculate. RL of B we have to calculate. Yes, so this is going to be the RL of point A is known to you. So RL of B will be equal to RL of A plus or minus RIA. For this example, the RL of A is known to you. As you can see, the B point is at the lower elevation. So RL of the point A minus H will be equal to the RL of the point B, na? Why you are considering plus? Why you are considering plus? Why you are considering plus? You have find for the A. Here it is clearly written that RL of A is known. Then you are finding the RL of the point. Why you are finding the RL of the point A? That we will also discuss, don't worry. Let's say, if the RL of the point B is known to you, if the RL of point B is known to you, now what will be the RL of point A? So that you can write that will be equal to RL of point B plus going to be the H. So always, whenever you will see any problem, whenever anyone asking any question from you, and this is the most common mistake, or you can say this is the most common practice, that due to this students are committing the mistake in the exam. Do not always get in hurry. First try to try to understand the question. And if you will develop a habit to read the question carefully, to understand the question carefully, at least you are going to save your 3 to 4 marks in your final gate exam. Because we are not working on this habit, always we are in hurry to answer. That's why we are missing some points. We are not getting the correct question what they are exactly asking. They are asking something else, we are providing the answer for something else. How you will get the marks for that? So whenever you will see any question in the class, or whenever you are practicing the question at your own, like you are practicing the gate previous year question, you are practicing the ESE previous year question, so during this preparation try to develop a habit. First of all, I will read the question carefully, I will patiently see what they are asking in the question, then I will apply the concept and report our answer. And it will take lots of time to develop this habit. Suddenly you cannot develop this habit just before the exam. Yes sir, I already think now I will not commit this type of mistake. In the exam you are going to commit the same type of the mistake, and for that there will be the penalty, there will be the negative marking. So it's my suggestion for all of you to try to develop this habit from today onwards. Whenever you will see the question, first take your time to understand that question. Because in the gate exam, they will also provide you the option like this, whatever possible mistakes you can commit in the question. Like if you are not getting the question correctly, if you are in a hurry, okay, no issue, it's not about today. I'm discussing some general guidelines which will help you. If you will follow those guidelines, so you can improve your preparation. That is the objective, that is the point. So in the gate exam, what is the problem? In the case of MCQ, there will be 4 options A, B and C and D. In the case of MCQ, there will be the 4 option in the GATE exam. If I talk about the MCQ question, yes or no, multiple choice question, obviously in the multiple choice question only one will be the correct answer. Only one will be the correct answer, yes or no? If this is the MCQ question, only one answer is going to be correct out of from all these 4 options. So let's say for example, C is the correct answer. C is the correct answer. C is the correct option. A, B and D are incorrect. But what you need to remember, what you need to understand in the case of GATE exam, they will not provide you these incorrect answers options randomly. Just try to understand, this is the very important point that you should know. In the GATE exam, they will provide you these options as per the mistakes that you can commit. So whatever possible mistakes you can commit in the question, whatever possible mistakes you can commit, they will consider that mistake, and based on that mistake, they will find the answer, incorrect answer, and they will provide you as an option. Are you getting this point? Are you getting this point? So there will be no random option in your GATE exam. And this is not for this particular subject. I am talking about the GATE exam. That means this discussion is valid for all the questions, irrespective of the subject. So as a student, whatever possible mistakes you can do, yes, they have already considered those mistakes and they have prepared the solution based on those mistakes, and what were the incorrect answer, they will also provide you the option. And if in the exam hall you are attempting the question and after applying the concept, after performing the calculation part, if your any options are going to match, so you are not going to recheck your solution. You will see, you will say, yes, I have solved the question, I got an answer, and that answer is on the options. That means it is correct. But there may be chance that you have got the incorrect option. This was the trap. Yes or no? So that's why do not commit these silly mistakes. These are very painful in your exam, because in exam each and every marks is very important. So if you are losing any single marks, that is going to affect your rank. Yes. So I hope the discussion is clear to everyone. So this was the concept of the reciprocal leveling. This was the concept of the reciprocal leveling. I hope the entire discussion about the reciprocal leveling is clear to everyone. So this is the conclusion. The true difference between the both points will be equal to, so based on these 4 staff readings, based on these 4 staff readings, we can calculate the elevation difference. And if we know the RL of any one point, with the help of the RL of that point and the elevation difference between the point, we can find out the RL of the another point. We can find out the RL of the another point. So I hope the discussion till now is clear to everyone. So everyone, please confirm if the discussion is clear to all. Clear, very good. So now we are going to see another very important topic, that is the sensitivity of the bubble tube. That is the sensitivity of the bubble tube. Very important topic and very simple topic. Very important topic and very simple topic. So we will discuss about the sensitivity of the bubble tube. So as you can see in this diagram, there is a level tube or bubble tube. Here you can find a bubble. A liquid is filled and here you will find a bubble. Can you see this diagram clearly? Can you see this image clearly? So there are some graduations, as you can see, and this is the bubble. This is the bubble. If this level tube is perfectly horizontal, try to understand. If this level tube is labeled about, if this bubble tube is labeled about both the axes, x axis and y axis. That means if we are considering the plane that is perfectly labeled about both the axis, x axis and y axis, on that plane, when I will place this bubble tube, what will be the position of the bubble? Tell me. If we are placing this bubble tube at the perfectly labeled plane, that plane is labeled in both the axis, x axis and y axis, at that situation, what will be the position of this bubble? Definitely, undoubtedly, you can say at that situation, the bubble will be at the center. Yes or no? Very easily you can understand this point. If the plane is perfectly labeled in both the direction, this bubble we will get at the center. Same concept we have used. Our telescope is perfectly horizontal or not. Our telescope is perfectly horizontal or not. That we have ensured by making the bubble at the center. Yes or no? That we have ensured by making the bubble at the center. So now for this bubble tube, I want to define a very important property, and that is the sensitivity of the bubble tube. That is the sensitivity of the bubble tube. So first try to understand how we are defining the sensitivity of the bubble tube. How we are defining the sensitivity of the bubble tube. So sensitivity of the bubble tube we can define with the help of this symbol, that said this symbol is alpha. So alpha is the magnitude of sensitivity of bubble tube, and it will be equal to rotation required for one division of movement of the bubble. Again I will repeat, don't worry. So how we can calculate the magnitude of the sensitivity for any bubble tube, that it is the rotation required. It is the rotation required to move this bubble one division. It is the rotation required for this bubble tube to move this bubble one division, that in this way we can calculate the magnitude of the sensitivity. In this way we can calculate the magnitude of the sensitivity. So again I am repeating how we are defining the sensitivity. Sensitivity of the bubble tube is defined as it is the angle of rotation required for moving the bubble one division. I hope the definition of the sensitivity is clear to everyone. I hope the definition of the sensitivity is clear to everyone. I hope the definition of the sensitivity is clear to everyone. Just to move your bubble one division, what is the rotation required? What is the rotation required that we are going to provide to this bubble tube so that the bubble will move one division? With the help of this we can define the magnitude of the sensitivity. With the help of this we can define the magnitude of the sensitivity. Please confirm in the chat box if the discussion is clear. Please confirm in the chat box if the discussion is clear. Here you can see a very important term is written like sensitivity property is inversely proportional to the sensitivity of magnitude. Sensitivity property is inversely proportional to the sensitivity magnitude. What it means? Sensitivity property is inversely proportional to the sensitivity magnitude. What it means? So for example, let us consider, just wait. पता नहीं क्या है, बट जो भी है, with the help of this I will try to explain this very important term, relationship between the sensitivity magnitude and sensitivity property. So I hope you can see these two object, yes or no? Please confirm in the chat box. I hope you can see these two object, yes or no? Both are filled with a liquid. Both these bottles are filled with the liquid. Yes or no? So I hope you can observe the bubble also. In both these tubes you will see a bubble. Yes or no? You are going to feel the sensitivity. This is the Engage perfume spray for women. Okay. And this is the Streaks hair serum. काफी चीजें हैं. I don't have hair, so it is have no use. कोई बात नहीं. Both are having the bubble is not visible. Don't worry. I will see. I will provide you the closer view. Then you will able to see the bubble. So you can see both these liquids are having the different properties. As you can see, this is the spray and this is the hair serum. So obviously the properties of the liquids are going to be different. So first see the bubble. So now I think you have seen the bubble clearly. Yes or no? Have you seen? Have you seen bubble for both the tubes clearly? Now understand the very important term. Let's say for this serum bottle, I want to move this bubble one division. I want to move this bubble one division. What I will do? Only in orange liquid. Let's see again. Yes. Now clear? Let's come to the main point. Let's come to the main discussion and listen carefully. And listen carefully. If I want to move this bubble one division, let's say here are the division. I want the size of bubble is large because the liquid is less. If we will increase the liquid, the size of bubble will decrease. Yes or no? So if I want to, some things you can assume, yes or no? So if I want to move this bubble one division, for that we need to provide certain rotation, yes or no? Without rotation, this bubble will not move anywhere. Without rotation, this bubble will not move anywhere. You can see. इस पोजीशन पे अगर मैं बात करूं, if I talk about this position, the bubble is at center. If I want to move this bubble, then we have to provide the rotation. Now I think it is clearly visible to all of you. Now I think it's clearly visible to all of you, yes or no? So let's say for this is the level tube A with orange liquid, or you can say this is the perfume, whatever it was, spray, and this is the level tube B. So if I want to calculate the magnitude, first I am talking about the magnitude. First I am talking about the magnitude. So for A, let's say, for A bubble tube and for B bubble tube, I want to find out the magnitude. So For both the conditions, we need to rotate our bubble, we need to move our bubble one division. And for example, for this bubble tube A, we required 5-degree rotation to move this bubble one division. And for the level tube B, we required 2-degree rotation to move the bubble one division. Any angle it is required depending upon the liquid or other factors, yes or no. So just for an example, if I am saying, if for the bubble tube A, 5-degree rotation is required to move the bubble one division, and for the bubble tube B, 2-degree rotation is required to move the bubble one division. So if I talk about the magnitude, so you will say, sir, sensitivity is going to be 5-degree for the bubble tube A, and the sensitivity for the bubble tube will be equal to 2-degree. Yes or no? That we can draw the conclusion from this example. Yes or no? This is the conclusion that we can draw. This is the conclusion that we can draw with the help of this example. Yes or no? This is the conclusion that we can draw with the help of this example. Yes or no? But this is the magnitude of the sensitivity. But if I talk about the sensitivity as a property, who is more sensible? Who is more sensible under the less effect? Under the less impact, the bubble is moving. With the small angle, the bubble is moving one division. With the large angle, the bubble is moving one division. I can say the bubble tube which is required less angle to move one division is more sensitive. Yes or no? It is more responsive than this bubble tube. Yes or no? This is more responsive than bubble tube A because it requires less angle to rotate the bubble one division to move the bubble one division, but level tube A required more angle for same one division movement. So now I think this point is clear to everyone. Yes or no? Now I think this point is clear to everyone. Now we can say the sensitivity property and the sensitivity magnitude are related to each other with inverse relationship. Which bubble tube required more angle will be less sensitive. Which bubble tube required more rotation to move the bubble one division will be less sensitive. Yes or no? Can we draw this very important conclusion? Can we draw this very important conclusion? Yes or no? If you have any doubt, any query, you can ask your doubt, you can ask your query. If you have any doubt, any query till now, you can ask your doubt, you can ask your query. So in this way, you can calculate the magnitude. In this way, you can calculate the magnitude of the sensitivity for any bubble tube. In this way, you can calculate the magnitude of the sensitivity for any bubble tube. Can we move further? Can we move further, yes or no? So now I want to discuss some more thing about the sensitivity. So as you can say, let's say, so for example, this is your initial condition. So let's say this was the telescope, and when the telescope was perfectly horizontal, so let's say this is your staff and this was the telescope. At this position, the bubble was at center. Let's say this is the position 1, 1. Let's say this is the position 1, 1. Now what we are doing, we are providing the rotation. So when we will provide the rotation to our telescope, let's say something like this, what will happen? What will happen due to this rotation theta? Due to this rotation theta, the initial position of the bubble was at the center. Now this bubble will move, yes or no? Due to this angle theta, this angle theta, let's say the distance between the level and the staff is d. Let's say distance between the level and the staff is d. So this white was 1-1 condition, and this, let's say, green was your 2-2 condition. This green is your 2-2 condition. We have provided the rotation so that bubble will move, yes or no? So that this bubble will move, yes or no? So if you want to see the position of the bubble, so earlier the bubble was at center. Earlier the bubble was at center. So let me use the same color so that there will be no confusion. So at 1-1, this was the condition of the bubble at the center. When we have provided this rotation theta, so due to this theta, let's say bubble moved n division. So this is the condition at 2-2. First, everyone please confirm this discussion is clear, yes or no? So we are considering two positions of the level tube or the bubble tube. One is 1-1 and another is 2-2. If I talk about the 1-1, there was a bubble at the center. The telescope was perfectly horizontal. We have provided the rotation. Due to this rotation theta, the bubble will shift, and now we want to go for the further analysis. So now we will see the further discussion. Can I say from this condition, from this triangle, let's say this is the point O. So from triangle O1-2, can I say tan theta will be equal to, this is going to be the staff intercept, change in the staff intercept S by D, yes or no? Because the theta will be less. Theta is going to be very less. So can I directly write theta will be equal to S by D? If you don't have any problem, can I write theta will be equal to S by D? What is this S? When when the level was perfectly horizontal, let's say this reading was S1, and when you have provided the rotation, now let's say you are getting the reading as S2. So S will be equal to S2 minus S1. S will be equal to S2 minus S1. Yes or no? Similarly, we can say, let's say the one division of this bubble tube having the distance of L, and R is the radius of curvature of the bubble tube. R is the radius of the bubble tube. So can I say this theta into R will be equal to N into L? From this diagram, can I write this theta into R will be equal to N into L? So theta will be equal to NL by R. Theta will be equal to NL by R. Yes or no? So this is your equation, let's say A. This is your equation B. So this is theta, this is also theta. So can I say A should be equal to B? So from here I can write S by D will be equal to NL by R. So now we can take the conversion degree radian, yes or no? We can convert, yes or no? So first we have found the theta with the help of the telescope. Second, we have found the same theta with the help of the bubble tube. And from both the conditions, now we can define the sensitivity. So what was the sensitivity? Alpha was theta by n. Alpha was theta by n. So you can put theta, one theta was S by D and another theta was NL by R. Another theta was NL by R. Dear, arc length will be equal to radius into this angle. This arc length will be equal to radius into this theta. So R theta will be equal to N into L. R theta will be equal to N into L arc length. Now the point is clear, yes or no? Now the point is clear, yes or no? You got it? Very good. So, from equation A, I have used the value of theta, and from the equation B, I have used the value of theta. So, can I say we are getting the two expression for S by alpha is equal to S by ND is equal to L by R, because this N and this N is going to get cancelled. And we know 1 radian is equal to 206,265 second. We know 1 radian will be equal to 206,265 second. So can I define sensitivity alpha will be equal to, from here you can write S by ND into 206,265 second, and alpha will be equal to L by R into 206,265 second. Tell me yes or no. And here also we can write S by N into D will be equal to L by R. Can we write like this? So in this way, we can calculate the sensitivity of any bubble tube in second, and this is the magnitude, not property. This is the magnitude of the sensitivity of the bubble tube, and we know which bubble tube is having the more magnitude is going to be less sensitive. Is going to be less sensitive if I talk sensitivity as a property. If I talk sensitivity as a property. So I hope that discussion is clear to everyone. So all the question you will get from these three equations only. And again I am repeating what are these terms. So alpha is the sensitivity of the bubble tube. S is the staff intercept from the position 1,1 and from the position 2,2. Whatever staff readings we were getting, we can take the difference, and that is going to be S. S is the staff intercept. D is the distance between the level and the staff. N is the total number of division that the bubble has moved. L is the length of the one division of the bubble tube. R is the radius of curvature of the bubble tube. R is the radius of curvature of the bubble tube. I hope the entire discussion till now related to the sensitivity of the bubble tube is clear to everyone. Entire discussion till now related to the sensitivity of the bubble tube is clear to everyone. If anyone having any doubt, any query at any point, you can ask your doubt, you can ask your query. The topic is important. You will get objective question, both theoretical and numerical. You will get both theoretical and numerical question from this topic, that is the sensitivity of the level tube or bubble tube. Sensitivity of the level tube or bubble tube. Please confirm in the chat box if the discussion till now is clear to everyone. Clear to everyone? Very good. So now let's see some more discussion related to the sensitivity. Sensitivity increases with. So this is important that you should know all the parameters which will affect the sensitivity. So sensitivity will increase if these are the things like increase in the radius of curvature, increase in the diameter of the tube, increase in the length of the bubble, increase in the smoothness of the intersurface, decrease in the roughness or at the internal surfaces. Agar roughness will decrease, sensitivity will increase. Decrease in the viscosity of the liquid, decrease in the surface tension of the bubble. These things are important from your theoretical exam point of view. Okay. And the last point, in the case of bubble tube, commonly used liquids are chloroform, spirit, and synthetic alcohol. The liquid that we are using in the case of bubble tube, that will be chloroform, Most common liquids are chloroform, spirit, and synthetic alcohol. So this was the discussion related to the sensitivity of the bubble tube. So in this way, in today's class, we have completed two important topics. In this way, we have completed two important topics. First was the reciprocal leveling, and second discussion was related to the sensitivity of the bubble tube. Sensitivity of the bubble tube. Till now in leveling, we have discussed about the plane leveling. Till now in the leveling, we have discussed about the plane leveling. We have also completed our discussion for the reciprocal leveling. We have completed our discussion for the geodetic leveling. So we are almost at the end of the leveling. And again, I am repeating, leveling is very important topic from your exam point of view. So if you are not practicing the PYQs, this is very wrong thing. Please do understand this point. Because we have completed almost 5 chapters, yes or no? Yes, first we have completed the fundamental of surveying. Second chapter we have completed the linear measurement. Third chapter was the compass surveying. Fourth chapter we have completed, that was the traverse surveying. And almost we are at the end of the leveling. Where can I get the subject? We are also developing on this platform. You will also get the PYQs there. So you can visit the app if you will get. But that video solution, previous year question related to the video solution PDF, all the things are in developing mode. Till then you can arrange from the internet. So you will get previous question very easily. Yes. You will get previous year question of GATE and ESE very easily. There is no problem with that. So do some effort. As soon as the things will ready, we are also going to provide you. We all are working on that so that you will get all the things systematically. You will get various options are available. You will get. So question practice is very important. So do attempt all the DPPs. I hope you all are attempting the DPPs. Yes or no? So sometimes there may be one or two questions that topic you have not covered may come because due to the some discussion. Sometimes some discussion is pending and DPPs we are recording earlier so that there will be no delay. So sometimes there may be problem with one or two questions. So don't get panic in the case of DPP, in the case of test. Because these DPPs and tests are recording prior to the classes. Yes or no? So in that case, do not get panic. But as soon as we will cover the topic, you will able to solve all the question. No problem with that. So for example, let's say in the last test, you have found one question related to the leveling. So now what you can do, as we have completed the discussion for the leveling, do attempt that question and cross check. Are you able to solve that question? And definitely you will able to solve that question. Okay. So next we will discuss the concept of the trigonometrical leveling. We will discuss about the theodolite. Further discussion are there. But this was all about for this class. I hope all the discussion from the today's class is clear to everyone. So see you tomorrow. Thank you everyone. Keep learning.